Hi, welcome back to Mouse Metrics. I'm Prati Kamasani, and in today's video we're going to look at how to create that validated layer or transformation layer. Basically make our data ready for presentation layer. In the previous video we looked into creating the logging and we applied the logging into one of the notebook. I went back and I applied the logging for all the notebooks. I also imported the data for all the cities that I wanted to get in the Europe. I also went and did a bit of tidy up in the workspace itself. I created a logging folder. I also created a folder called to be delete. It's basically, I kind of do that in my laptop itself. It's a similar thing. It's like you kind of can keep everything in that one. Finally, you could just delete everything in that folder once you finish with your project. But it just helps to keep the consistency, and also the workspace looks nice and tidy. So the ingestion layer that we have done so far is the easiest thing when it comes to any data analytics project, because you're basically ingesting data. You are keeping it most of the times in the raw format, and or putting them into the Delta Lake tables, but you're keeping the same column names, you're keeping the same data types and everything, you're just checking in. But when it comes to the transformation layer or validated layer or curated layer, that's where the solution design comes into the place. And one main thing which impacts on the solution design is what do you want to do with your data that you ingested. In this project or in this solution, there are two things that I want out of this data. One is to be able to see the patterns, how the weather has been changing over the time. The second thing is how the places is impacting on that pattern change. Maybe if I add the third bit, it's is there any correlation between the income levels of the countries and what kind of weather they have? Is there anything there? Is there any pattern there? But basically I want to do a bit of patterns. That's my end goal. And based on that, I want to create my validated layer. Now I'm switching between transformation and validation, but it's basically the same thing. So in the validation layer, a few things are very important when it comes to building the validation layer. Because in the raw layer, I just ingested data. I didn't have to care about what kind of data I'm working with, how clean my data is, and what are the data types I have in my source data, because I kind of just pulled and inserted. But when it comes to the validation layer, I want to understand what kind of data I'm working with. Is there any dirty data? Is there any data that I need to be transforming, or do I have to filter down some data? Are there any duplicates? All this kind of analysis that I need to do. The other thing is how is my destination table is going to look like, what data types I'm going to use, what kind of columns I want to include. And this is where things like slowly changing dimensions and factless facts and all this kind of nice modeling concepts kind of comes into this validation layer. Again, in this project, I'm not doing all the slowly changing dimensions and all those things, but however, I do want to be able to create my destination tables with a nice structure. And in any project, it is nice to create something that you could use somewhere else, automate it wherever you can, or make it dynamic wherever you can, so that it can be used somewhere else. So that's kind of things that I'm going to focus in this session. So to begin with, I'm going to start with a lake house. I'm using the same naming convention, except I'm using the validation layer over here, and I'm not using the schemas again. Not going to create a new notebook here. In fact, I'm actually going to go to my folder and create a new notebook so that it actually sits in the folder. And I will attach my raw lakehouse. So as you could see, there are so many tables over here. I have most of these tables belongs to the weather data, and I also have some demographical information like raw countries and other World Bank countries and things. I would love to have a little search bar over here so I could go to the table that I want very quickly. But to begin with, let's work with the World Bank countries. Right, I'm going to start by choosing the right environment, and then I'm going to work with the World Bank countries. Let's execute this. With a quick glance, I could understand there are some blanks available in my latitude and longitude, and however, I'm looking at only 1,000 rows, but I can see there are some missing data in my data set. I could go and open this data frame in a data wrangler. I could use this one for profiling. It is very similar to the Power Query experience. I'm not going to do that. What I wanted to do is to be able to make it dynamic and make it in a automated way. So for that, I have this script. Let me first execute the script and then I will talk about it. So my script is executed. From the output, you could see I have all the columns, and I also some of the characteristics about those columns, like I am checking if there are any nulls, any blanks, special characters, and things like that. And you could straight away see there are quite a few blanks available in latitude and longitude, and so does in capital city. And there are some other columns as well. So what's happening in the code is I am providing the data frame that I have above, which has only 1,000 rows to begin with. I'm providing that data frame, and then I'm profiling the columns of the data frame over here. So I'm kind of just using a few conditions, and I'm checking, does it have any nulls? Does it have any blanks? What is the minimum length? What is the maximum length? So it's kind of goes and checks the entire data frame. So it could be quite time consuming and quite resources heavy. But in this case, I'm working with only 1,000 rows to get an understanding about what kind of data I'm working with. And I don't have to do it every time. This is very much a data profiling exercise to understand so that I could create my destination delta table with the right architecture, right structure basically. So from here, I understand there is lat and long and stuff like that. So if I go and see this data in the SQL endpoint, as I could see, most of these blanks are coming from aggregated values. So for my solution, I don't need those aggregated values, so I could just go and exclude them from my data frame. So now I go and create another data frame. In this case, I'm actually giving a right naming convention, and also I'm not using only 1,000 rows, I'm actually getting all the data. But however, I'm excluding the rows where there is a latitude or longitude is blank. And this is my data now. And now my data set is pretty much in a stage. So this data frame is pretty much in a good shape to keep it in my next stage of the data transformation. But however, when I look at the column names, I could see my latitude, longitude are still strings, and so does all the rest of the columns. Because this is a small data frame, I could go and update those columns to decimals or whatever the data type I want it to be. But if I'm working with a data frame where I have so many columns, and if I have to do it for multiple tables, it's not really feasible. So that's where what I'm looking for is to be able to provide my data frame as an input, and I have a piece of script where it could tell me, it looks like the data frame and it tells me, like, based on the data that you have in this data frame, this is the data type which would work. It may not work 100% all the time, but it will definitely speed up my development process. So that's what we're going to do next. So this is the piece of code which basically does that. When you look at the output, you could see it's taking the data frame as a input. So this is the data frame where I'm giving it as an input, my filtered data frame, and then it's profiling each of those columns and suggesting me a data type. And finally, it's also giving me a schema that I could provide for my destination delta table. So let's look into the code to understand what's going on. So there are two functions I'm working with. One is suggest data type, and then generate schema. Generate schema is basically, it creates the schema for me in a format so that I could just copy and paste it in my next code block. The suggested data type is, it's taking the column data. Column data is basically the data frame, and then it goes to each column and says, It's try to like, is it in data, is it decimal, is it date count, and things like that. And based on that, it increases the number, like for the int count and all those things. And then depending upon what count I have, it's basically suggests the thing. I'm not working with every possible data type, but you could extend this code to however you want to. The next thing what I'm going to do is I'm basically going to copy this schema and put it into a code block, into a variable. So this is my code block. Next thing what I wanted to do is convert my data frame to this schema. So before I actually convert it, let me have a quick look at this schema. So this is the print schema for my data frame, and you could see that latitude and longitude, they both are strings. And next thing is I want to update my schema with this new schema. So for that, I have created a little function so that I could use the same function in all the notebooks. So I created my function. So if I execute this command, if I do the print schema again, and you could see my latitude and longitude are the decimals based upon the new schema that I provided. And again, all these scripts, it doesn't have to be done every time. It is very much for the profiling in the beginning. So now what I do is, now I know the schema that I'm working with. I don't have to rerun all these codes again. So, but however, I keep them in the notebook for the further reference, but I will just comment them so that next time I'm running, I don't have to execute all these other steps that I needed for my profiling. And I will also go and clear all outputs. I could even go and hide inputs as well. I could tidy this up a bit. So the next thing I want to do is to incorporate logging and then insert the data into my Delta frame. So first I would actually just begin with the constants and all the variables that I need. This is all the information for the logging. These are all the variables related to where I want to keep my destination data. And these is basically copy and paste from my logging framework, which has my logging information and also the various functions that I need to capture my logging data. And the next code block would be actually the main code block where I will be writing my data frame to the destination. And this is my main code block where I am writing the data into my destination. I am providing the destination information over here where I'm like the constants or the variables, and then finally I'm also logging the data into my logging framework. So if I execute this, and if I go to my logging framework, I should see this is the data that's been saved and how many rows has been inserted and things like that. And this is where the logging is very useful from my perspective. So this works perfectly fine for my World Bank countries data. I want to do the same thing for the cities. Instead of creating another notebook, I'm going to use the same notebook so that I don't have to create all those functions and everything again. Ideally, I would probably keep these functions in a resources folder so that I don't have to copy and paste between the notebooks. But for this solution, I'm just going to copy and paste it, and probably I'll do another video where I will be talking about how to create this framework, including how to keep everything in the resources and a more elegant way. So first I'm going to get the cities data into a data frame, and then I'm going to keep that one into my destination table. I also added nice headings for entire notebook. So if I go and view the table of contents, I have my logging framework, and then I have probably the logging framework should be heading 2. Then, so to begin with, I have my logging framework, and then I have some functions for my schema preparation. I'm doing a bit of data profiling for the World Bank data. Don't need that much profiling for the cities because all the all the data types are pretty good. And then I am doing the loading data into from my raw layer to my validation layer. I have two code blocks. One is for World Bank countries, and then I have another one for world cities. I executed both of them, and if I go to my logging and if I re-execute this bit of code, I should see two rows which shows me how many rows been inserted into world countries and how many rows inserted into world cities. And I don't. I made a mistake and I ran a couple of times. The first time I actually used the wrong data frame, so it inserted 211 rows instead of the original rows. And then I inserted the right data frame, so it inserted the right number of rows. And then finally rows inserted is coming as 0 because my calculation is basically rows before and rows after, subtraction of both of those. That's why it's 0, which basically, because it's an overwrite operation, it's basically 0 rows. Maybe I could change the calculation or rename the column names over here, but it makes sense. Yeah, so this is what's going on here. I'm just using the rows before and rows after. So in this operation, because it's an override, it's 0 rows. So this works nicely for my countries data, nicely logging. I could go back into the logging framework and see all the profiling activities I have done. I'm going to comment them so I don't use them during my orchestration and use the resources unnecessarily. The next thing is the other set of tables which are related to my weather data. When I look at my lake house, I have a table for each city and I have 2 cities for each country in the Europe. When it comes to my validator layer, I don't want those many tables. What I want is a one fact table, which is a union of all those tables I have in my raw layer. On top of that, I want to profile the data to make sure if there is any data that I should exclude. I want to use the right data types based on the data I have in those tables. And I also want to have the logging like we did so far. And I also want to include error handling because our data is coming from the APIs and I may not always have the APIs working perfectly. So if I keep it in the orchestration and if I put it on schedule, sometimes if I'm getting some wrong data, I want to handle that data so that my orchestration doesn't fail. But however, I'm capturing that information somewhere. So for that, let's start creating a new notebook. Before that, let me actually rename this notebook. Going back to the same folder, and I'm going to start a new notebook. I'm going to start bringing a table and display the data. It's probably worth going and getting some country that I'm actually familiar with. So I'm going to go and get UK, but I'll let that run. Actually, I just realized I'm going to stop it. Choose the right environment first. I can actually go to my workspace and make sure in the workspace setting I'm using the right environment. All right, going back to notebook. I have the right environment and let's execute it. So I have a date column, which is a combination of date and time. And I also have the ID column, which is basically the same value for all the IDs. So it could be like a city information. I also have the country and city information. So to make my life easy for the semantic modeling, what I'm going to do is to split this date column into weather date, weather time, and also add an extra column which will capture the information about my source table. In this case, like United Kingdom, London, that information. So if there is anything wrong with my data, it will make my life easy to go and debug. So that's what I'm doing in the next bit of code. If I display this, as you can see, I don't have date column anymore. I have weather date and weather time as 2 new columns, and I also have a new column called source table, which is nothing but my source table column. It's a literal value which is repeated for all the rows. Next, I wanted to do profiling. I don't want to exclude any rows, but I do want to make sure I have the right data type for my destination table. For that, I will be using the same code that I have used in the previous script. It uses this data frame as the source and it suggests me the data types. However, my code is looking at only 100 rows, but I do want to change it to 500 so that I have a bit more data. Especially in this case, I do have the data available for most of my rows, but if I'm working with the data frame where some of the blanks or things like that, then it may come back and suggest me a different data type. So in that case, I do want to go and increase my data frame. It does take longer, it uses more resources, but however, it's a one-time thing, so at least I can have the right data type. So this is the data type it come back with, and if I have a quick glance at it, it is pretty sensible. So the next thing what I want to do is basically create a variable and copy this schema and paste it here, and there you go. That's the variable which has my Europe weather data schema. The other thing I could do is I could copy this code, put it in the Copilot, and now it gives me in a bit more readable format, so I could nicely see like in what kind of data types it suggested. Again, it's a small data frame, so easy. And I could go and convert my data frame with this schema. Do the conversion, and if I do the print schema, now I could see I have the different data types compared to my original data types, which is here. It's showing me float, which is okay, but when it comes to weather date and time, it was showing me string. But if I go here, now I have date and the time is still in string format, which is cool. So that's cool, but this is only for one table. What I want to do is I want to be able to doing it for all the tables in my lake house which has weather data. For that, what I basically just going to do a loop. So this is a piece of code which is looking at I'm providing my lake house name. So this is where my data is. I am doing like a show tables in the lake house, and then I am filtering because I have the naming convention of hourly underscore weather data for each table wherever I'm bringing this weather data. So I'm basically looking for that table, that postfix in my entire collection, and finally I'm keeping the table into a list. And the next piece is basically easy. It's like me looping through all these tables and appending the data into my destination lake house. I'll go and add that piece and also incorporate the logging into it. And once I have all the code, I will go through what's happening in the notebook. Alright, there's a lot going on in this script, and I came across some things that I haven't expected. So for example, when I go to my tables and when I go into city like a Vatican City, let me actually open it in the lake view here. So if I see the ID column in London table, it's coming across as a text. But when I see the same column in the Vatican City, it's coming with this brackets around it. And if I see the same table in SQL endpoint view, I have this little warning symbol and I don't see ID column at all. And if I hover over on that warning symbol, it says me that this column is a void column. And when I see the data, when I use select 100, it doesn't include that ID column at all, but I still can see my data. So I need to handle this in my notebook. Right, going back to notebook, so quite a few things happening here. So let me put the table of contents. I was actually in the wrong notebook. Now I'm in the right notebook. If I open the table of contents, you could see various steps that's happening. To begin with, we are importing the libraries, all the libraries that's been needed to execute this notebook. Then we're doing the data profiling, which is very similar to what we've done previously. Just looking at the data, understanding what kind of data that we are working with. We're checking if there are any null values and things like that. And then we are also, based on the subset of the data, we're trying to get the structure so we could use that as a schema for our destination data frame. That's pretty much what's happening in the data profiling. And then I am doing the logging framework. For the logging framework, the start time it's interesting. I mean, I still have to figure out exactly where is the right place to keep the start time. But if it is something that we are in a recurring base happening, for the comparison purposes, it doesn't matter as long as it's exactly the same place for all the executions. But anyway, so I'm keeping the start time in the beginning of my logging framework so that it helps me to understand how long this process took. And the rest of the things are very similar to what we have been doing previously. So I'm gonna hide this one as well. Next thing is the schema prep. So based on the previous profiling the data, we understand what is the schema structure that we need. And based on that, we are basically doing this function is similar to what we've done previously. This is a function which is new, but it is, as the name says, it is basically to handle those void columns. And to handle the void columns, what I'm doing is I'm basically just dropping them from the data frame. But however, the void columns are there only for some cities, not for all the cities. So when I'm appending the data frame where there is not all the columns are there, it was throwing an error. So what I was doing is I'm kind of actually adding another, using another function to make it sure, based on the schema, these are the expected columns. If that column doesn't exist, add it as a new column and use a default value. But again, based on the type of the data type, I include what type of a default value it should be. I created it this way in the hope that, if the same situation happens somewhere else, I could just use this function for all my development work. And then I am also doing the reordering so that whenever you add a new column, it kind of goes at the end. So I'm kind of reordering in the same structure as my schema. And here it's basically updating the schema, which is similar to what we've done previously. Next thing is main code block. We have various variables here. We have destination variables, which basically includes what is the table name, where this table name to be saved as, what kind of operation type we are working with, what is the lakehouse name. It's basically we're building the destination save path. And we also have some print statement for the debugging purposes. And then we have logging variables. This gives you pretty much exactly same information, but we are building the logging save path. One extra thing that's happening here is we are also building an error table path. So the error table is basically to redirect whatever the errors you have in your process into a table so that you could go and view them. Having an error direction, this is something that we used to do a lot in the SSIS world, where so that you're not interrupting your data pipeline. If there is an error happens, it goes into error table, and then you could send a notification to whoever responsible for the process saying there are some new errors, go and have a look. So it's I'm going for a similar approach. I'm not sending a notification to anyone, but however, I'm capturing errors into error table, which is sitting at the same place as my logging information. Next comes to tables. We have lots of tables in our source. Pretty much all of them have the same naming convention. So I'm going and looking into all those tables, getting my entire list of tables into a list. And next, I basically want to loop through those table names. So the next block is where I am inserting all the data into the next layer. I have two sections under this. One is preparing the error schema and then appending the data into my final destination for this notebook. The error schema, I am creating a schema where I'm capturing 3 columns: table name, error message, error date. That is what I feel like good for this solution. But however, you could include so many more things to that one. And I have a little function which I would use at the end of my main data block. So it basically captures the table name, and whenever there is an error, that error exception, and for the date time, I'm just basically using the current time whenever this notebook gets executed. To begin with, I'm just using a list and I'm creating that error list. I also have a bit of commenting code here. It's basically to make sure that schema and the definitions kind of working. So let's see what's happening in the next block. So what I have here is I have various tables in my lakehouse. I want to combine all these tables into one fact table into another lakehouse. I want to loop through all those tables. And then, because I want to do only incremental loading, there are few scenarios that I'm working with. First, I'm going to check is the table exist or not. If the table exists, what is the maximum date and time for the selected city? And then I'm going to check, filter my source, based on whatever the maximum date and time I get, filter my source table to give me only the data after my maximum date and time. Then I use that subset of the data and append that into my destination. And then finally continue with my loop so that go and get me the next table. And if the table doesn't exist, I would basically just do the full load and continue the loop. But there are some other scenarios as well. Sometimes table may exist. Sometimes there could be another scenario where table may exist, but table may not have any data in it. So then, like, is the table blank is another scenario. And if the table is blank, then also do the full load. So these are like various scenarios. That's kind of what I'm doing in that notebook. And one other thing that I'm also doing here is like checking back what is the max date and time for the selected city. Instead of doing it every time, I'm doing it one time and saving that in a data frame. Going back to notebook, first thing first, I am checking if the destination table exists. And if the destination table exists, what is the destination row count? If it is greater than 0, then get me maximum date time for each of the source table. And then I'm keeping that into a dictionary so that I could easily go and get the maximum date and time for the table I'm working with. The next thing is basically looping all the tables that I have. It's kind of going, checking what is the maximum load date time for this table in the dictionary that we just created. And it's also going and getting me a data frame from the source for the table I'm working with. And then it's removing the void columns. If there are any void columns, just remove them. And then it's doing some filtering and checking if there is any new data. It's kind of similar thing kind of happening in the entire code block. It's basically checking these scenarios, like if the table exists, do the filtering and then append. If the table doesn't exist, do the full load. And if it's also checking if the table is blank, and do that one. I'm sure there must be a smaller, you could change the code to make it a bit more smaller. But for me, I think this is a bit more understandable to understand exactly what's happening in each condition way. The other thing that's also happening here is about the error capturing. So this is where error capturing is happening. So first it tries to insert the data or append the data into my destination table. And if there are any exceptions, it raises an exception. It's printing in a statement for the debugging purposes, and then it's logging that error with the table name and the error information into my error table. And here you could see like all the errors that happened when we are trying to work with the data. If I go to my Lakehouse monitoring and to error log, I could see all the errors that happened, including the error message why my pipeline has failed. I think metadata like error logging and the monitoring information, it really makes a difference when it comes to the maintenance of the solution, because it's not only like a development. Many times when we're designing, we're so much focused on designing and developing things, but we forget like how is this whole entire solution is going to maintain, and what happened when things goes wrong. And this kind of metadata capturing very specific to the solution helps those situations. So for now, I'm not going to bother about all the errors that happened. I'm just going to focus on the data that I managed to capture. That brings us nicely to our curated layer.